Hello and welcome to episode 17 of the PM Blend. I'm Mark Powell, co-host Joe Finksler. Joe?
Hi, Mark. Having a good day?
I'm having a great day.
Hey,
How are you today?
We've got repeat guests, so I'm doing great.
We do. And we're at episode 17. There hasn't been enough time between 16 and 17 for Ann to replace us. So We're back for another episode. But this episode is part 2 to quality in PM, where we're going to talk about NDT and other quality testing. We've got our guest, Andy Recker, back with us, automation engineer.
Yes,
here
thanks
at
for
Dallas.
having me back.
Andy?
It's a long drive over here.
Yeah. Thanks for sticking around. Appreciate it. And then our special guests today, Jeff Monks and Brian Butch. Jeff from EquipCon and Brian from the Modal shop.
Yeah.
Thanks for coming back, guys.
Well,
Again,
glad to,
we're sticking around. How we want to say it. So, but we're excited to have him back. If you didn't watch the episode 16 on residence testing, we're going to refer back to that a little bit here, but definitely want to pick up on that episode. So that was episode 16.
Yeah, that's
so,
covering a lot of ground.
Yeah, especially in quality, it covered a lot. So I definitely would encourage you to watch episode 16 if you can.
Yeah, that was a lengthy episode for us.
Yeah.
You might need a box of popcorn to eat that.
Maybe in a frosted beverage too. Maybe skip the popcorn, have 2 frosted beverages while you're watching it. But anyway, so we'll get into these other NDT testing here. So as we discussed in the previous episode, what other NDT methods other than resonance testing are used in powdered metal?
Obviously, depending on the location, the product, the customers that they're making parts for, the types of technologies we would typically see beyond resonance would be magnetic particle, occasionally penetrant inspection, eddy current inspection, sometimes ultrasonic, depending again on the end use of the product, and some type of radiography, whether that be just simple X-ray, more often than not for the real benefit of that inspection for your industry. I think CT is probably where these parts would go when radiography is required. So with CT, you're able to look just layer by layer at a very fine detail through the part and find internal flaws in any direction, basically, depending if you slice this way, or this way. And you're able to find internal flaws and issues that may occur. So there are several NDT methods. The big normal ones were mag, penetrant, X-ray, ultrasound, and eddy current. Vision now is considered an NDT test. Obviously, resonance is an NDT method as well. And through the years, we've added a lot of others like holography and laser inspection. So as technology improves and develops, the NDT methods continue to grow as well. But the main core of the NDT world would be, the initial 6, including resonance.
So why are those other methods required, Jeff?
Good question. While resonance inspection, we just said in the last episode, as we were chatting, that it could find all of these types of problems you have. But there is no one answer for all questions. Okay, so when you are inspecting a part, the inspection required will determine if it's an internal flaw or an external flaw, like surface, or is it a material property change? What exactly is being inspected? What are you inspecting for? You want to ensure that the part is free of something. So knowing what that criteria are will help you determine the method, where resonance can be a volumetric structural test of the entire component. It may not be finding everything, and other technologies will be specified anyway. So if you're looking for, in some industries where you're extruding parts, you may be looking for, you can call it a pipe inclusion. As you start to extrude a part and it's hot, the inside of the part may have a hollow section as the part is being drawn over. That's done in casting, like continuous casting as well. You'll end up with that pipe inclusion. Resonance may be able to detect that, but it's not a proper use of that technology. Typically, you're going to have a high temperature inspection being done with perhaps an ultrasonic EMAT to find where that stops. In your industry, magnetic particle, we mentioned in the last episode, was a very popular test, and it's still used extensively, but not at 100% much anymore. because resonance has been able to fill that gap, right? But we also talked in the last episode about occasionally a very, very minute surface indication may not be detectable with resonance. And in those cases, magnetic particle is perfect for that. With an AC field, you'll find very small surface indications. So depending on what you're trying to do and the reason for why you're doing it, that determines what method is best used. Eddy current, I know Brian mentioned last time, looking at hardness values, perhaps broken teeth, which again, resonance can find, but certain technologies and techniques. And normally when you combine techniques, you have the highest assurance that a part that passes your 100, 200, or 300% inspection is indeed without a defect that's going to cause problems to that part.
Okay. Are there advantages to one over another?
Of course, yes. Resonance we like the advantages of because it's dry and no consumable materials. Magnetic particle and penetrant require liquid materials and time. Mag particle may take 1 to 5 seconds to inspect a component, whereas resonance is very fast. Mag and penetrant are very, very, very sensitive to very, very minute and shallow surface cracks. Resonance may want a little more depth to detect as well, because you have to actually have structural impact, not scratches on the surface. So you can detect certain things with mag and pen you cannot do. But then the test itself, mag and penetrant, almost the same for sensitivity. Mag, if you have a ferromagnetic part, mag particle works fine. If you have an aluminum part or a non-ferromagnetic part, you have to use penetrant. You're detecting the same thing using fluorescent pigments and black lights. It looks the same, the indication, but the penetrant may have to dwell on the part for 10 to 30 minutes. And then you have a whole wash process to remove the excess penetrant and to dry it. But if you're in the aerospace industry and looking for very minute flaws, you have to do penetrant when it's called out. So you're in a marketplace where, depending on the end use of your product, that will determine what inspections have to be done. And if it's not done by you, it will be done further in the process or use of those products by somebody else.
Yeah, it's a good point. Like you said, the resonance, for instance, you typically run that at the end of the line, inspect it, 100% it, pack it, ship it. Whereas if you use the penetrant and it needs cleaned, you're typically sending that maybe out of house to get cleaned, to come back to get back to ship. So just the cleanliness of it.
Or adding a cleaning process in-house.
Correct.
Right. And there's electronic tests as well, like ultrasound, like eddy current, that can determine certain information about a part. But again, those are typically called out by purchase order, by the end user, and the applications being used for. In your industry, the most common methods still are mag, eddy current, and resonance now. And I think that anybody who needs to do a serious study of their parts, certainly during the early days, is going to be using CT or at least X-ray in an outside service lab environment.
Okay. Joe had mentioned in the last episode about the cleanliness of resonance testing. So it sounds like that is one advantage of that, but it sounds like we have cleanliness with eddy current anyway, right? I mean, and some of these other methods as well.
Right.
Okay.
Right.
All right. Are inspectors required to hold a certification for NDT?
Typically, yes. Again, all of the core methods, mag, penetrant, ultrasound, eddy current, X-ray. There are level 1 inspectors, level 2 and level 3. A level 1 you would consider essentially an apprentice. They know how to perform the test, but they're not authorized to interpret the results. Level 2 can follow the procedures and interpret pass-fail criteria from indications noted in the inspection. But level 3 is responsible for the training, the procedure writing, and so on. So there are different levels of qualification. There is not yet a resonance technique inspection requirement for personnel qualifications. It is a fairly automated system once you're set up, but I think that at some point that's probably coming down the pike. AS&T, ASTM, they're recognizing the method more and more.
Yeah, don't they call that like the ASTM International, like I saw this, and the only I wrote it down because I wanted to ask you about it. It was a E3397-23 standard.
Right. So,
Yeah, so that standard, I actually was on the team of people that we worked to develop
I
that
thought you
standard
were.
and release that standard. Yeah, so that 33 was 3397.
3397.
Yep. So that standard is the standard for resonance testing. It defines how you perform a resonance test from start to finish. And it covers several different resonant methods, not just the modal shops
Correct.
type of resonance. So based on having a standard, that's where ASTM, or not ASTM, excuse me, ASNT, the American Society for Non-Destructive Testing, once you have a standard for a specific test method, then you can create certification levels
programs.
where people can be trained to a level of certification. And also add to what Jeff was saying about the certifications, the requirements of certification is also going to be dependent on the application, the criticality of the application, right? So in the aerospace industry, everything's critical, right? So all those inspections and inspectors are going to have to be certified. In a lot of the, like if you're looking at like commercial products, automotive to a point, things like that, like there's not as much criticality there, or you're doing spot checks for some of these other NDT methods. You're not necessarily going to have to hold a certification in order to be able to perform that testing.
Right, correct. And the personnel qualification is AS&T has CP189, the S&T TC1A, which are standards covering the personnel qualification requirements, minimum requirements. They also have their what was called the central certification, where the actual employee maintained their own certification rather than the employer, which was historically. And then throughout the world, there's several other, I don't want to call them competing, but they really are competing certification programs. So where that ends up eventually, I don't know. But Brian had started to say it's the criticality is one reason or one determiner as to what type of certification you need, but also your customer will eventually likely say, we need your people certified to such and such if it ever goes to that. But also your own quality manual as well. So your program may say, Andy, for instance, is an in-house expert. He is authorized to do this type of work, setting up testing and developing criteria. And the folks that he trains, because he's authorized to train them on operation, are capable of, bringing the system up, pulling up the program for the specific part and ensuring that it's working correctly, and then running production. So it's not cast in stone. It's not hard and fast as to what you have to do yet. I think it'll be interesting to see how a method that can be fully automated eventually does fall into requirements. For instance, in the steel industry, in long products like a continuous casting line making sheet or steel plates or blooms and billets and bars, right? There's a lot of inspection done using NDT systems in line, where the inspector is actually a line operator in a pulpit. What level of training do they need to make decisions as to what's being inspected automatically?
Yeah, especially if the system's kicking the stuff anyway. So
Right, or at least determining the disposition of that based on flaws detected. So you get into a level of automation where the certification becomes questionable. There will be, I'm certain, certification required for every NDT method. As an industry, we're not getting more lax, we're getting more stringent, and that will continue.
I'm just thinking of someone tuning into our podcast, wondering what am I getting into? I this sounds like a great fit for my my product here. What do I need to do? What certifications do I need to get? Where do I need to start? So, thanks for touching on that.
Yeah, I think currently in this realm, there's nothing. But you have to have somebody in-house that knows what they're doing and set it up, that's trained by the factory or ourselves, and you keep that going for now. And eventually the determination will be made by others what the certification level has to be.
What the customer wants.
Exactly.
In the powder metal industry, specifically in greater St. Mary's area, powder metal capital of the world, we don't see at least I haven't seen a lot of people at the plant level that are holding specific ASNT certifications for specific methods. But there are companies that provide parts testing services in the area and around, and those people that are accredited. They're accredited for quality standards, but they're also holding the certification levels, the ASNT certification levels for those different methods. So if you send parts out of house for specific inspection that you don't have the capability of doing in-house, those inspectors are typically going to hold certifications.
That's a good point. Very good point. Yeah, yeah.
Joe, I'm kind of stuck on one word that Jeff used, or expert. Yeah. I don't know that we're going to be able to get him out of the room when this is over. His head is just getting so blown.
I'm getting my business cards changed. I know that. Marketing.
We're casual observers, but
Can you guys come back again?
When you go to a plant,
how much did you slide under the table to him to say the word, Andy, expert?
Yeah, when you go to a plant, there's somebody who's always called when there's a question about something, and I've seen that it's this guy right here
no, you're right.
in your plant, so that makes
You're
him my
absolutely right.
expert in-house.
No, I would agree.
That's really a good thing.
But we couldn't let it slide.
Well, now across the street in the production facility, they call me Fluff, which I like expert better.
So I know we kind of touched on this, but I'll ask it anyway, Jeff. Why is NDT performed at all? If the process is good enough, is the inspection necessary?
So NDT I've been in NDT for 37 years. My father was in the steel industry. He was the first level 3 in all methods of NDT in steel in history. And he didn't bring me into this industry. I ended up in it by mistake because one of my brothers was in it as well. And then my third brother, he was in NDT for a short period and went to work for Navistar. My second oldest brother is an OBGYN who uses ultrasound and X-ray and magnetic resonance imaging. So I said, you're in NDT as well. You're just looking for problems in the body. We're looking for problems in materials. Same thing. You end up in it by accident. And in fact, when it comes to why is it used, typically in a industry that has not had to do NDT in the past, they despise the technology. For many years, every welder hated the fact that they had to be an X-ray welder, they called it, meaning you could pass X-ray testing and bend testing on your weld coupons. And in every other industry, it came with great resistance. So NDT is only done because you're told you have to do it, either by the code you're building to, or the customer PO saying you must inspect this before you ship it to me. And so over the years, we were always fighting that we were the stepchild nobody wanted in an industry. But back about 25 years ago, we switched direction as to how we promote NDT. And NDT is no longer that requirement that everybody hates to do. NDT actually now is being used earlier in the process, becoming part of the process controls, and utilizing your NDT as a process control is now giving you the final potential use or motivation, which is return on investment. So if performing NDT is going to make you more money because you're making less scrap, you're shipping more product in a shorter period of time, you're maintaining control of your inventory through the entire production process and not needed to send it out for a week to this lab or a month to that lab to have other testing done, you're able to do it all in-house, it becomes desirable. So NDT is either regulated by law or code, by customer requirement, or by your own edification desires of saying, let's get a return on investment and be sure that we're producing only good product.
And Mark, that's part of the reason why we even brought the initial stuff in that we brought in, and these guys have grown it the way that we have internally, is because the objective was we're trying to ensure that nothing bad is getting to our customer. It wasn't because a customer came and stood on us and said we had to do it.
Right.
We're trying to find the better mousetrap to stop other types of inspection. Visual inspections, individual inspections are not good. So the more we can automate and find other ways of doing it, it's much better for the end product.
Well, even to touch on what you had been in the industry for 37 years, you know, technology obviously has advanced in that time, making it easier to implement, to automate. I know for when I had started at Atlas, the frequency range on our NDT area was only at like 50,000. You know, we did some updates, we did some software upgrades, and brought that up into the 100 range, and it's improved not only our process but the parts that we can inspect.
Detectability improves with more criteria available and more frequencies, more chance of finding those specific resonant frequencies that matter.
Whereas that might have not been available 37.
My days in the industry, my first time in the powdered metal industry was probably early 2000. I was out in St. Mary's. I didn't know you guys or anybody else, but there was a company here that was performing inspection for all the powdered metal companies that were developing their businesses, and they were using magnetic particle extensively. And I had developed a magnetic particle system that was fully automated, multi-directional, and non-contact. So no clamping apart and passing high current. It was all multiple induced fields to inspect in every orientation on virtually any part, simply a dynamic test going through a tunnel being sprayed, magnetized, and the inspectors were viewing and accepting or rejecting. That system was fantastic for back then, but frankly, resonance is a cleaner method, less costly method, and where you're not required to perform mag particle, it could do that test for you. Where you are required to do it, our system could do that faster than any other system made. And with resonance on the inlet to that system, you're doing 200% inspection, and the cost of the resonance is fairly invisible compared to the overall cost for what you're required to do. So the NDT is done because it has to be or because you want it to be, and that's determined by whatever the motivating factor is, your requirements or your desires.
To add to something you said, Joe, a minute ago about how at Atlas you guys aren't being pushed to do the inspection, but you want to do it because you want to provide quality parts. Just to back that up, in all the places that I've been, in all the continents that I've been on, most companies have the mindset where Jeff was saying of, we're only doing NDT because we have to. You guys are one of the much smaller percentage, 10% or less of companies that really
experts.
That's it.
That's you.
Yeah. But you guys embrace inspection. Like, I could go pick 10 quality managers at 10 different companies, and 8 of them will say, "Oh, we don't make bad parts." Bad parts get to customers. If you don't make them, I don't know what happens. But you know what I mean? But everybody makes bad parts. Things happen, right? Nothing is perfect. The manufacturing process is extremely robust. It's amazing. Pick a manufacturing process, powder metal, casting, forging, whatever it is. It's a robust process, and most parts, you can try to make a bad part, and usually they're still going to come out good. But having the mindset that you guys carry of, we want to make sure that we're only going to ship good parts to our customer, and we know that even if we run into a problem, we figure out the root cause, a setting in the press, the way the parts are being injected, a lube issue, heat or time in the furnace, whatever those things could be. If you fix that issue, it's invariably going to come back at some point in time, right? So having that mindset of, we're going to do this inspection, we care that we're going to make sure that we're only sending the best out to our customers. I mean, it's the best business model you can have, right? If you don't have happy customers, you don't have customers. If you don't have customers, then you're not in business.
And I'll add to that as well. We do have a lot of customers in various industries who will purchase their NDT equipment that's required. They'll train the minimum number of people that they have to based on the requirements to run it. Many times they'll bring other people in and train them below them and use them perhaps where they shouldn't. And they don't service or calibrate the equipment. I mean, the commitment to quality has to be from the manufacturer, and they have to let that propagate throughout their organization. We have a lot of people using resonance inspection because it's very, very reliable. They choose not to have routine maintenance or calibration done, and that is adding a big risk to something. So we are stressing to all of the existing users that while it's a stable method, you really should have it looked at. If something's going wrong, you may not know about it. You know, you're not passing, we're not making any bad parts for a long time. Isn't that great? Well, let's make sure that's the case with a high degree of confidence, ensure that the supposed good part is without a defect. That's what NDT is. That's the positive acceptance criteria, not a rejection. It's not a rejection procedure. So the commitments from the company when you use it correctly, the use of NDT by gun to the head or a requirement, it's less effective. So if you have to do it, learn to love it, own it, and get your company to feel the same about it, because it is important.
I think we just look at it as another step in the process.
Yeah, right.
We, it doesn't take us anything to put it at the end before we ship it out the door to run it through and double check it.
Whether it's in a quote or whether it's in a new part review.
Right.
Like one of the initial gate reviews, we're asking the question, is this something that we need to add on? Do we feel we've got exposure? And if we're going to have exposure, that puts the customer at risk.
Absolutely.
And
We don't want to do that.
we don't want to do that. We want to protect the customer.
That customer, that relationship with that customer.
Yeah, absolutely.
Yep.
Is there a layered approach where multiple NDT methods are intentionally used together?
Yes. Again, depending on the application, depending on the part and the industry and the requirements. Oh, just here, we see a lot of powdered metal companies that are doing eddy current, visual, and resonance. Several of you have mag particle equipment in-house, meaning you're doing that at times as well. So different defect types, different requirements that you're living to will require different methods. It's important to understand the usefulness of all of the different methods to understand, right? Resonance is a volumetric test, and when you get a frequency change, you're able to use that very, very reliably. But where you don't, now what method could I use? So understanding the methods, if you'd like, I can get you a chart that's like a selection chart of all of the common methods, and maybe you could use it in here as an attachment where it'll list all of the NDT methods and what they're good for. It's a little, limitations and benefits or uses.
Yeah. I think the gears you mentioned in the last episode, there's multiple NDT methods used on those.
Oh,
right?
there is, yeah.
Yeah.
And it just in our facility here,
Yeah.
we use different methods all on the same part.
On the same part.
Yeah.
Yep.
There's not one size fits all.
Exactly.
So how do part complexity and critical function influence the choice of the NDT method used?
In standard methods, the part complexity dimension plays a big role, right? In magnetic particle, you need to have a acceptable length to diameter ratio in order to mag that part at all. If you don't have the LD ratio, you can't do mag with a coil. So then you're doing multiple shots through a headstock, which may or may not work, or finding another method to do it. In ultrasonic inspection, if you're doing a normal beam test, looking at time of flight from the top surface to the back surface, that will find internal voids, flaws, laminations, or just give you an accurate thickness measurement by measuring the time it takes for flight to make a round, or sound to make a round trip. If you have unparalleled surfaces, you can't do that test very easily, right? So the dimension, the complexity of the part, those all come into play when you're performing an NDT method. And this is why your toolbox should be full of a number of choices of NDT methods. You have resonance. It doesn't mean it's going to do everything. You've got eddy current in a automated system that's not going to help you for something that won't fit in that system. Every method has its own usefulness, but where you're putting signal or something into the part and receiving it back, you have to have the part conform to the way that signal has to travel. So normal beam UT compared to shear wave ultrasonic that goes at a shear angle. The main method, UT, ET, PT, MT, is not always adequate. You have to go deeper into that based on the part complexity to determine how you inspect it. Your rings, for instance, would need a central bar conductor. perhaps your ring should use a threader bar, which is creating magnetism in a different orientation using a magnetic particle. You don't want to clamp the ring because the teeth are going to overheat from high current passing in it. So the actual setup and process and procedure is always based on the part complexity and geometry.
Okay.
No, I know you
material.
spoke of the coil. You know, you'd need a different size coil. They only make so many sizes of coils you need to run the parts through. Each part's a different diameter.
Right. Yeah, and we would never suggest doing a coil shot, as they would call it, on a round ring-shaped component. There'll be a central conductor bar and a threader bar, which is basically transformer laminations, which creates a totally different toroidal field in the part. So there's a lot of different ways to use the common methods. And that is a great question because it's not as easy as I have a yoke or I have a bench or I have a tank system or I have aerosol cans. You really have to look at the part, the volume of the part, the requirements that are being put on you, and that determines all of the rest of those questions. So as you get into more complex uses of very common methods, there's a number of different directions you may have to turn based on the actual requirements.
Okay. I have a just to add to that. So thinking about part complexity in the metal and excuse me, ceramic additive manufacturing world, 3D printing, part complexity, the complexity of the structures that are being printed has gone up tremendously, right? You see parts where it used to take hours of machining, you'd have to assemble multiple parts together. Now you can print those as a whole piece just in one shot as you go, which makes for a very complex component, but it also introduces a lot more potential for defects in different areas of the parts. Inspection's really a challenge on those. And especially with 3D printed parts, as they're printed, you have generally more surface roughness than you would from a traditional PM part or a MIM component, something along those lines. So in thinking about what NDT method could you use in a part like that where you're trying to find potential defects in the part, methods where you have to insert to input a signal like an eddy current or an ultrasonic, because of the surface roughness and the complexity of the parts, you might not be able to even get a signal into the part, or if you're getting a signal into the part past the surface of the part, all of those complex pieces of that structure, you're not going to get that signal to travel through there, right? Yeah. Same goes with liquid penetrant or magnetic particle. The surface roughness and the complexity of the structure might make it extremely challenging to be able to find surface flaws, cracks and things.
Yeah, very rough surface
within
typically
there.
fluoresces heavily just from the background, so it may mask an actual indication.
So like for an example like that, something where you're really left with visual, X-ray, or resonance as the main methods of actually being able to inspect those sort of components. So it gives you a good, just a specific application example really of how you would go about selecting the NDT method that you would use for that particular part.
And never assume that one is the method for everything. We could tell stories about equipment we've built where customers said they could inspect anything with it, and we suggested, no, you're really better to take apart if you don't have a rabbit to throw through and verify that it's set up correctly. And they wanted to use what is called a QQI, which is a quantitative quality indicator. It has notches on the back side of a very thin metal shim, and you put that on your part for mag particle, and it will show a cross, meaning two directions of magnetism, and a circle. So on a multi-directional magnetizing, the full circle should fill in and maintain those particles. And they felt that was good. But the shim is actually measured in the air. So to prove that on an induced system like ours, we put their shims on all four sides of a 2x4 at about 5 feet long and sent it through the system. And we were able to prove, according to their theory, that we could inspect wooden 2x4s with magnetic particle inspection for flaws in any orientation. It's not true. But you really want to ensure that the test you're doing has thoroughly thought through what you're trying to verify is good. Okay, so after you submit a part to an NDT test and no indications are found on it, you have two conclusions you could draw. One, there are no flaws and the part is good. The second one, which is more common ignored and shouldn't be, is the right procedure wasn't there, like a QQI and a 2x4. So you need to ensure that the test you set up takes into account all of the variables, and that you choose the right test or tests in order to prove that the supposed good part is indeed good.
I would assume that your interaction with our group, especially with Andy and Luke, has found that we're open to have those dialogues with you so that you give us the feedback, because we understand, even though he is an expert.
Well, thanks, Joe.
We are always open to be challenged
Yeah.
in whatever we're thinking about.
Right. We would normally start with your in-house expert.
We use 1x4s, not 2x4s.
Well, I think the last question I have is, what role does production volume play in the NDT method chosen? I know that Brian had mentioned in our last episode that resonance testing, you can test one part per half a second. So obviously that's maximum speed. So that's obviously very efficient. But what role does production volume play?
In selecting the method, I think it's a very it plays a role, right? But the actual inspection requirement plays a bigger role.
Okay.
I
it
think
definitely isn't the determining factor, is not necessarily volume.
it may be a determining factor where you have two or more technologies could achieve your stated goal. And then one is just faster. Okay, obviously, if that's provable, use that one. But typically, the test is going to say you must detect this using that. So the biggest challenge in the industry, really, which is where we focused our efforts for the last 37 years at EquipCon and myself, was to look at integrating technology that's normally done manually. So ultrasonic inspection for laminations usually requires steel-toed boots, really thick knee pads, good gloves, and sensors that you're going to scrub on a steel plate continuously until that shorts out because it's worn out the surface, and replace the sensor and keep going. We do it with a system inline, doing it early in the process. So you have a requirement to do ultrasonic testing for laminations or pulsed eddy current for hard spot detection. You could do it manually, or we bring it into the production line. So the actual technique is usually required by the specification.
Okay.
When you get lucky and you've got a few solutions, then you choose the most simple one to use or easiest to integrate.
Yeah. Otherwise, you have to get creative and figure out ways of whether it's automation and integration or different solutions of how to employ that method to speed up time.
Yeah, even working with these guys, we still have to automate it.
Right.
And we have to present the part, we have to impact the part, we have to get a signal back.
And
make a decision.
That part after the
Correct.
signal. And in the some industries, we have requirements for magnetic particle, or pardon me, for ultrasonic and eddy current test methods. So in those cases, we and our partners will combine our sensors into a common sensor where it's doing multiple tests through one sensor. Why not? You're saving space, you're saving electronics and structure to drive those with. So the creativity doesn't stop. It just gets more interesting each year as to what has to be addressed as specifications become more stringent.
And the nice thing for us, Mark, is as we've already kind of touched on, a lot of the times we're getting involved in this, it's because we're choosing to do it. We're not being directed by some authority, a customer or a standard.
Right, yeah.
We're doing it because it's the best method to get the end result for our customer. And so that's where it's nice for Andy and the group to be able to reach out to these guys and have some input and get thoughts on different ways of doing it.
And that thought pattern is not totally unique to you, but it is more unique than you would think in industry. So the fact that you guys are already at that point of seeking out better technology, bravo to you. That's a great place to be in an organization. And it seems like all the way from your expert on up, you all you all adapt that goal.
Thanks, buddy.
Yeah. And you're going to end up with a license plate that says expert. I can see it now.
It could happen.
I'd be surprised if it didn't. So,
I do know a recent application that we just had was a part. The residence was kicking it out, but there was no visual defect. We couldn't see the visual defect on it, but we could see the signature of the something was different between the known good that we had established, and it came back to some of our tooling we had changed, and when we resurfaced the top of it, we took a depth down.
Oh, okay.
And that caused some internal pulling, and we figured it out right away in the residence. Helped us to find.
Right. Normally, when we get a call like that, we have these parts and they're failing. We don't understand why. Our first thought is it's probably got a defect. It's failing, so something's different, right? Determining what that is takes a lot more work, and that's where we work together on those. But I think recently we had a question about a part here that I believe we're waiting on a couple of sample parts for us to do a little work back at our shop.
We are. Yes. But so we typically don't involve Jeff because he's the expert. We step up.
You have your own experts.
In general, though, like as far as taking NDT data and applying that towards the larger process, there's a lot more than just the results of the part that you tested. If you look at data on a time scale or just lot by lot, things like that, you can pull a lot more information out of the NDT data, whether it's resonance, eddy current, magnetic particle, visual, whatever, and really apply that back to how can we improve our process? How can we make less bad parts? How can we make parts to the most perfect part that we could possibly make? Take that data and loop that all back. You guys do a good job of that. There's some places that do as well. It kind of follows that whole mindset of if you put quality first, right? And if you're thinking quality first, like, hey, we embrace doing inspection on parts. We embrace making the best parts that we can. If companies that have that sort of mindset sort of think in that whole range, not just part by part quality, but start to finish.
Right. I think one of our strong points here is data. Data is knowledge. The more data you have, the better informed decisions you can make. Mm-hmm. And I've noticed some of our parts, say especially a ring, we do some OD grinding to it, and whether that we grind it a little too much or that part's out around, I'm starting to notice the data in the NDT systems is slightly off and changing based on the grinding operation that was done previously to that part. So we're making informed decisions to mold that part maybe a little bit smaller, or to heat treat it or center it differently.
Or your concentricity at setup and things
to
like that.
center it differently so they don't have to grind as much off, so we don't see that variation in the NDT testing at the end. Yeah, we're seeing that.
Well, you all are using your technology and your data the right way, and that process control usage makes you more reliable to your customers and hopefully improves your bottom line as a manufacturer. You shouldn't spend so much time making bad parts. You guys are doing it the right way, so that's great for you.
It's still manufacturing.
That's it. Yeah,
You're still going to stumble into it.
well, thanks, guys. We appreciate having you back again. Okay, Brian, Jeff, thanks.
Yeah,
Andy,
thank you guys.
great having you.
I will come back. If you call me an expert, I'll come back tomorrow and the next day and the next day.
All right. Well, don't sit by your phone.
Okay.
Okay.
I'll be out on the floor.
Joe?
Mark, we all set to wrap up?
I think we're set to wrap up.
Okay.
Thank you for watching episode 17 of the PM Blend. And again, please follow our socials.